computer. Let's go with that. Okay. All right. This is the fourth incremental compilation meeting. And we have the agenda that Wesley has prepared. Oh my, and linked from Zulip. And so we still don't have like a regular cadence yet for in terms of like, you know, standing agenda of triage and whatnot. Maybe work that out later. But let's see what the status is. Maybe we can quickly just look over the agenda and collectively see if there's anything that anyone wants to add, so everyone can skim over it. I will mention the bullet points there briefly. There's something about a pull request from Santiago through his inline function duplication. David has a draft pull request for split debug info. Aman Aurora, who is not present, has opened a pull request for anonymous query nodes. And does anyone here know anything about that offhand?
He's been talking to me a little bit about that.
Okay, all right, then I'll let you perhaps tell us about it. And then Wesley is working on adding more detailed tracing data for the self-profiling. So is there any other agenda items that anyone else wants to add to this? No. Okay.
Do you want to talk about issue triage at the end of the meeting? If we should start.
Yeah, you know what? If we have, I'm assuming we probably will have time. So let's add that as an item to the meeting and see what we come up with. Okay. But let's go ahead and talk about the things that are here first, since you took the time to write us up. I want to hear about it. So we'll start things in order. So we got this Santiago's pull request to produce inline function duplication debug builds. Is this the one that like turns off inlining, like even inline always does it, or did you change the behavior there? The inline always even doesn't even inline anymore, or is that something else?
No, last week I was working on some other stuff, so I didn't like do anything with this yet. It's half baked, so we should continue like we should finish this one, but yeah, it's in the same state it was last week.
Yeah, so it is turning off inlining for inline always in debug. Okay.
Since
we don't run the inliner anyway.
Right. I remember that now. We talked about that. Okay. And then it says here that you're looking into regressions connected to this?
Yeah, there's some decent wins, and there's a couple small losses on some of the more what's the word?
The micro benchmarks or something?
Yeah, the micro benchmarks. I would not really have expected to see that, so I'm a little curious what's going on. So I started digging into that, and then that's kind of what led to my other bullet point there, which is just trying to figure out what's going on. So
when I followed the link, I think there's some sort of error with perf right now, because when I followed the comparison link, I got an error decoding response body expected value at line 1, column 1. So I'm assuming there's something wrong with some service that we rely on. That might be perf across the board though. So I'm going to assume it's not our problem.
Yeah, it was working last night, so I think it's probably perf. But.
Okay. All right. Is there anything of interest? Since I can't see the comparison data, I don't know offhand which micro benchmarks are the ones that are failing. Is there anything of interest yet, or even just naming the ones that are cases?
I don't remember exactly offhand which ones it was, but I think the more interesting thing to me was the losses were typically like 4 or 5% or something on some of the micro benchmarks, and the interesting wins were on things like I think the regex crate and some of the larger. I think one of the servo crates actually had a 3 or 4% performance improvement on not just the incremental benchmarks, but even the non-incremental full debug compilation.
Sure.
So I feel like those wins are probably much more significant than the losses in the micro benchmarks, but it would be good to figure out what's going on a little bit more before we just decide to merge it. So
it was on, which ones was it on? It was on, you said regex or servo?
I think it was regex and one of the servo ones. I forget which one. It might have been servo script or.
I remember that regex for sure, but yeah.
Okay.
Like, yeah.
Gotcha. Okay. Yeah. No. Definitely something to push forward on, I think. Okay. Now we've got, next up is a pull request from David on split debug info. Okay, which I don't think we had last meeting. So
I brought this up like days after the last meeting. It's currently working. You can give the flag and it'll produce objects that have split debug info stuff in them, and you can run GDB and it'll load them and stuff. The problem is that right now we're outputting the dwarf object files per cogen unit, which means we have tons of them. And so we need a solution to link those together. So there's just one with the binary. The problem is there's not really any way, or there's not many existing ways to do that. There's a tool called DWP, which can link the pre-standard GNU flavored split dwarf, but not dwarf 5 flavored split dwarf. LVM picks whether or not to use GNU flavored or dwarf 5 flavored based on the target. So I don't think that's something we can change. Even if we were able to link them together.
What features would we give up if we were to do that? Do you know?
I don't think there's much of a difference. I think it's just that dwarf 5 is the way to do it going forwards.
Okay.
Okay. And even if we were able to link them all together, we wouldn't. There's no tool that I can find that would let me change the dwarf attribute in the linked binary to point to the new single file rather than the 12 individual per cogen unit files. It seems like that's just not something people. It seems like the split dwarf stuff is something that there's not been a massive amount of investment in terms of ecosystem-wide kind of tooling to use. So we could add support to DWP, which is part of binutils for dwarf 5 linking, but then we would need to depend on that version of DWP if we wanted Rusty to invoke it. And I don't know how long it would take for that to go into distros and things. We could write our own little tool that does this. I don't know how much work that would be. That's, I think, the most promising approach. By the way, it's a problem that needs solved. I'm not entirely sure the best way to go about it.
Okay. I'm not familiar with split debug info, but I'm reading over the issue now that Michael Worster had filed, I guess, 4 years ago about it. So I see. It's just something where it's just so we all are on the same page about it. It's something where there's a lot of time you spend processing debug info, I guess, at load time or at linking time.
In the debug info, there's some that requires link time relocation and some that doesn't. And it takes the stuff that doesn't require link time relocation and it moves it either to a separate file or it changes the debug info such that the linker knows to skip it. In either case, the linker skips it, and that's where you get your time savings. And so the whole idea is that we put it in a different file, or you add the annotation saying it's in the same file, but the annotation still is enough that the linker knows to skip it.
This is interesting. I really, this shows how I really am out to lunch in terms of how this all works, because I had thought that when you had the debugging part in a separate file, that it wasn't something that the linker had to work with. So I had sort of thought those things are already naturally like this, that you all the time spent in the debugger.
That's how it is. It's just by default we don't have a different file. Yeah.
Okay. All right. So what do you think next steps are here then?
I'm going to, I think, experiment with writing something hopefully small using like Gimli or something to rewrite the attribute that says here's where my dwarf object file is, so that I can link them together and then change that in the binary.
Do you think so? In terms of like the time that we're spending on processing debug info, like you've identified this as being a big enough of a speed hit and link time that it really is worth investing in making your own tool?
I don't think we'd be able to land a solution without having some solution for this.
Right, but in terms
I don't know if it makes sense. I've not really looked into what type of wins we could expect from it. It was just on the work items for the working group. Oh, it's fine.
I see. Yeah, I just don't want. There might be other things potentially, other work items that could have a bigger bang for their buck potentially.
Yeah.
So if you're already in a groove like working on this, then it makes sense to just keep plunging forward. But since it sounds like you're talking about making a whole new tool, does sound like a kind of radical shift in the amount of effort potentially. So I want to make sure that that you keep in mind there might be other things that
I think it would be quite a win. I know that in like debug builds we have gigabytes of debug info.
Right. And I know
that seems like it would be a win.
link time is definitely a place where we are getting hurt big time.
Yeah.
Couldn't we get an estimate on the max improvement by basically disabling debug generation?
That's true.
And then comparing. Yeah, that's a good point. And then looking at the link time linker takes for those two things.
We have some intuition for that when you enable debug info for RC. People say that takes hours and hours longer.
Right. If anyone does that experiment, a good thing to do would also to try to look at not just the time but the memory usage. I'd be really curious to know if the linker memory usage is blowing up in this processing the debug info, if it really is or if it's just a time issue with processing the stuff. Okay, and also the other thing to look at potentially, if one is evaluating these things, is see if LDD, if for any reason LDD does a better job in terms of like where the time goes. It's probably because I know a lot of people say that if they switch to LDD, the link step gets dramatically faster. It could be that on things like this, it's better, maybe, or not. I don't know. It's just something to think about. If you decide to take the time to actually do a little bit of benchmarking rather than jumping into the actual solution, then I would consider these other points to evaluate. But also, it could just be you're better off just jumping into the solution. Okay. Next we have this pull request regarding anonymous query nodes that was contributed by Aman Aurora. Wesley, could you have thoughts on this? There's no description on the PR even.
So this was something Michael filed an issue about a couple years ago, and the thought, it sounds like there was not actually any performance data, hard performance data gathered. It was just kind of this might make stuff faster. Basically, there's some queries that don't depend on anything in the tie context struct. They just do stuff with their arguments, and we allocate dependency nodes in the dependency tree for those things. Even though they should be like relatively cheap to compute, and we don't actually need to do that or whatever. So this PR basically adds a way to have anonymous dep nodes, which really just are kind of more like, I believe, like gaps in the dep tree, and they just sort of forward any reads they do to the ancestor or the descending queries or whatever. The initial perf results don't look, let's see if they load.
I see that at least Bjorn said that they didn't load for me, but Bjorn said that there's up to 0.4% slowdown. There's other characteristics we should be looking at though, right? In terms of like the amount of space usage of the actual dep graph that's been serialized, right? I'm assuming that'll be smaller.
Yeah, that would be worth looking at. I guess I'm sort of feeling, I'm gonna look into this a little more, and I think maybe ping Michael and say, hey, does this look like a reasonable implementation to you or not?
That's right. It could be just wrong.
And assuming it is, I think if we're not really seeing a performance boost here, it does complicate the query model a little bit. And unless there's significant space savings, I'm not sure. I think this may just be we close the issue and say, tried it, and it doesn't actually yield much or any of a performance improvement. So there was never really perf data showing that this would be worthwhile to begin with. It was just kind of
it just seems like a good idea, right? Yeah, it's very interesting. I wouldn't have expected such a significant slowdown, although without seeing the whole chart, maybe it's not that bad, on average.
I mean, most across the board, there are some speed ups, but everything is very minor. It's like plus 0.2, minus 0.2, plus 0.3, minus 0.1, just all down the board. So.
Okay. Interesting. It's also possible it wasn't done quite right. Yeah, like you said. Okay. Good to try to ping Michael. All right. And finally, this Mike Wesley's got work on detailed tracing data for self-profiling. So yeah, what's the situation here? Is there an actual PR? You're just got something in progress?
So there's a PR open on Measure Me, which is the library.
Can you link it?
Yeah, let me grab it. So it's not actually that interesting at this point because we've had support in that library for multiple arguments being recorded in the event that gets recorded in the trace file for a while now, but there's not actually an API to generate those from calling code. So this is literally just that API, and then there's some other work that's happening there. So we need to land an update on Rust C to actually take advantage of this, which is in progress. But once that's done, what I want to do is for every cogen module node we have in there, so we already have those nodes and we can see what the cogen unit names are and how long they take for LLVM to process them. What I'd like to see is what our estimated costs are. And ideally, if there's an easy way to get at why we're generating this, which is not that interesting for full compilations, but in the incremental case, it would be interesting if we could get some sort of data about, we're re-cogenning this because this one method or this one function changed.
Yes.
So
yes, that would be awesome if we could get that kind of information out.
There may even be more detailed tracing stuff we can do at the mono item level and say this changed or this didn't change.
Oh man, I just saw that Michael was active 3 hours ago. Did anyone tell Michael about this working group?
I should mention it to him.
We should invite him to join. Sorry. Okay. Okay. Yeah. This is this looks really great. It seems like Michael himself, reviewed the PR recently. I don't know. This looks like a great. I mean, it'd be good to work towards the exact thing you described. All right. This actual PR isn't that complicated.
Yeah, like I said, I thought I was going to have to add support for all this, and it was actually there all along. Like we just never actually took advantage of it. So
right, this is just adding a constructor, exactly. Okay. Cool. All right. Well, we're halfway through the meeting now. So let's go ahead and I guess look at the issues and see if we can do a little bit of triage on the fly here. Like I said, I have not done much. I'll at least since you all clearly have said what you've been working on, or these things you've got in flight. I'll just say once again, I have not done very much with incremental violation since our last meeting. I've been focusing on finding a job, but progress there has been very good. So I will have good news to share, I think, in the very near future. But yeah, that's my report. Yeah, my Rust contributions have been focused on, if anything, I spent a little time last week on just release stuff that didn't go anywhere for me. Okay, so label is incremental compilation. We currently have both the A incremental compilation label as well as the working group incremental compilation label, which may be unfortunate. I don't know. What I suggest we do first is we look at the actual things labeled working group incremental violations, and sort of things are for whatever reason been tagged with our team, and see if they're all things that we we'll obviously skip the ones that are related to issues that we already touched on. And then if we get through this whole list now, then we can look at the broader list that are tagged A incremental violation, which is a much longer thing that consists of 108 issues. The working grouping, okay, so the working grouping violation issue has 9 open issues. I'm gonna post both these links in the HackMD, while the other one that I'm saying we probably won't get to, but if we do, is the broader list of all A incremental violation issues, and that's 108 open issues.
So every issue tagged with WG incremental comp is also tagged with A incremental comp.
Okay.
Should we just get rid of the working group? label?
I don't know. Well, it could still have meaning in terms of being something like a way of tagging something that's being actively, like at least that our team sort of acknowledged existence of, and perhaps even is working on. Like there's potentially useful semantics here in terms of what the label means, or it could just be confusing. It's a good question. I personally am okay for right now with leaving it, but I'm not the one doing triage, right? And I'm not the one that's and so if it's confusing to other people who are trying to figure out what labels to add, which is a situation I've been in, I can understand that. If nothing else, the fact that there is such a disparity between the two labels, I'm still tempted to say let's not just change it yet. Let's just at least go through the list as it is right now and see if there's anything useful in terms of the fact that there's these two different such disparity in the sets. Because if we get rid of working group compilation, I don't know, the fact that there's just 9 issues that are open here tagged with it, like I said, there could be some reason that it's like that. Okay, so I've got this set of 9 open issues. The first one is on my list that I linked above is 65023, which is error unused attribute const function union with incr-comp compilation. It's assigned to Ollie right now. I don't know if that's something where Ollie self-assigned it.
That is, yeah.
This is a little bit older, I guess. This is something that's from last year. Santiago filed it and filed a workaround. Was it actually fixed? There's so many things linking to it. Santiago, do you know if this has been fixed?
Which one is it? Like
sorry, 65023.
It looks like there was a workaround merged on May 28th.
Yeah, so unfortunately, it's the kind of thing that's probably hard for us to quickly check, right? If it's an internal attribute, let's see. Oh, maybe not, because the bug report is based on recompiling the compiler. We're obviously not going to test that right now.
yeah. I remember I remember more or less what this was about, but yeah, like impossible now to reproduce this again.
But the workaround isn't necessarily fixing the actual bug.
Yeah, right.
My immediate question is whether this bug is one that affects anyone that's like, is anyone using this outside of the compiler itself, right? Like, is something where fixing the actual bug has value, or is it something where the workaround, solves the problem for anyone who actually is using this thing? Oh, it's been whitelisted too.
Yeah,
that's.
I think the issue only affects people working on Rust C.
All right, you know what? I'm tempted to say close this fixed then, personally, or close this worked around. Like if our current hypothesis is that it's only 50 people working Rust C, let someone else file it if there's some reason that it matters in other contexts. Does that make sense?
Do we want an issue? So it sounds like, oh, interesting. It looked like Mark Simulacrum asked for a comment saying, hey, this should be fixed. And it wasn't actually added in the PR, but we merged the PR.
When you say, Mark, on the PR, the first PR.
Yeah, on 72713. If you look at the files changed diff, or I guess Aaron asked for one, but we didn't actually do that. Yeah, I don't know. I mean, it seems like maybe we want an issue to track turning this back to normal. It sounds like that's what is supposed to happen, although it also sounds like whitelisted is maybe just supposed to go away.
Right, it's just an anti-pattern.
Yeah. I guess we could close it.
All right. Yeah, I think there's a broader issue here that I don't feel like we should invest our time in personally. So yeah, okay, I'm just gonna say closing as worked around. Okay. Okay, so let's close this. All right, next. Next up, let me clearly say the number. 64291, hard linking incremental files can be expensive. This was opened again last year. Seems like there's nothing. Right, because this working group existed before this working group existed. This label existed before this working group existed. That's part of the confusion here, I suppose. This is an example, I guess, of how, the label usage can be confusing. So clearly we don't have anything to report here because we didn't look at it as far as I know. So they're just reporting that, that just takes a long time to incrementalist to link this stuff. But they're talking about literally hard links on the file system, I think, right? Am I misunderstanding that?
Yeah.
At first I was like, these are talking about the linker. No, it seems like it really is talking about hard links, I guess. Which is interesting.
I wonder if this or something similar is also an issue on Windows. I doubt we use junction points, which I think are the more supported way to do hard links on Windows, but we may just be copying this stuff back and forth, and file system performance on Windows is generally bad anyway. So this might not just be Mac specific. This might be anything but Linux kind of issue. So.
Yeah. Okay, so let's make a note about that. Like, I will mention you in this comment.
Which is just to say, maybe this is worth investigating on Windows as well, because there could be a similar kind of issue going on. So,
you know if junction points are fast on Windows anyway, or you're saying that since we probably aren't using junction points, it probably.
I'm guessing they're not using them because it's pretty rare from what I've seen for tools to actually use them.
Right.
Like the build tool for .NET, MS Build, it just copies everything everywhere all the time. And it doesn't actually even really support linking. It does in an experimental way, but like the product we work on at work has hundreds of megabytes of output DLLs, and I tried turning that on to see how much of a performance improvement it would be, and it was like shaving 40 seconds off a clean build, but it totally broke the tool afterwards. It just straight up doesn't work.
So Najisa did point out, which is similar to my reaction. Najisa pointed out here saying your operating system taking 0.2 milliseconds on average to do this step of hard linking seems so excessive that they wondered, like, was there something else wrong with your system, or maybe with what we're doing, like on a gross scale. So there's potentially some investigation warranted here in terms of figuring out what's, like, whether other people observe this, and whether it's something else that's wrong. It's not deeper than just a broader problem than just the link time itself of incremental violation. Having said that, the big question that's immediately asked to the incremental violation itself is this question of, can incremental produce fewer files? I don't think so, not without changing the architecture a fair amount, right? Like, I mean, I guess you could imagine some way to, like, instead of having files, you store the binary data in a single file. I don't think that's, you're just replacing a file system with a database, right? Like, in some fashion. It'd be a lot of work, and it'd be pretty questionable. Like, trying to be competitive there seems hard.
Is there a way we could avoid linking them 3 times? Maybe
that's the other question that is interesting.
Like, maybe we're trying to be too smart and use, I don't want to say too advanced file system features, but at least some of this stuff doesn't work as nice on other operating systems as it does on Linux.
Is it possible the reason that we're doing that, though, the reason the written 3 times could well be because we're trying to be robust in the face of, like, someone control C in the middle of a compilation and not wanting to, like, have something move to a place where we should find out why we're linking 3 times, right?
Yeah, I'm just wondering, could we do something simple, like, what if there was a text file at the root of the incremental directory that said, like basically laid out, pretend as if these file system links existed or something. You know, like what if there was a Rust C specific mechanism for doing this kind of thing and said, you know, here's a flat listing of all the files. These ones are in the new folder. These are in the old folder, or these are
you're right.
in the new tag. These are in the old tag. And that would probably.
You're right. That would work. And that's not like, it's one of those things where my intuition, my immediate gut reaction is sort of like, why would that be faster? But in fact, I could readily imagine why that would be faster potentially. And it would be fine in terms of like, so it should solve the problem fine, I think. Because it's hard to imagine cases where that wouldn't be fine. Yeah, right. So, okay, that's an interesting thing to look into.
Because I know we do have a fair number of bugs related to file systems specific behaviors or things not being implemented or whatever, and the incremental system. So maybe we should not try to lean so hard on the file system, and we could close a lot of these bugs in the process.
Latter might be, yeah. So it's like, yeah, okay. That might be potentially really simple, maybe. I mean, or maybe not. It depends on how deep we like end up using the file system. But you could imagine abstraction of a virtual file system that we could, build on top of, and then switch back and forth between these two, bases of the actual file system linkage versus the text file we're talking about. And then that way we could evaluate things. It might be a little bit of architecture to put in. The other question is, and then when I mentioned virtual file system, there is the point there that I know that MacClad has spent a while on virtual file system stuff for the purposes of IDE support. So it could well be that we'll more broadly want virtual file system stuff for Rusty in general. So it's possible there's some cross-cutting interests there that we should look into.
Yeah.
Okay. There's potentially interesting things here. Okay. Let's look at the next issue. So the next one is 55500, which is incremental compilation is ineffective when building compiler. I think that's why a lot of us are here right now. So yeah. So this is another old bug. This is like 2 years old at this point. It's almost 2 years old at this point. And it would be interesting to redo the sort of benchmark that Aaron posted. So the bug as described says it took 15 minutes after simply running touch on a file. Given that nothing changed, they expected that this would be much faster. There's been some changes to x.py itself since then. So the benchmark as described here just might not even measure the same thing today that it did then. So I am a little bit, I'd be careful about just rerunning the benchmark as described and then declaring victory if it doesn't take if it takes less than 15 minutes. But also there's a question there about maybe Aaron didn't realize that they didn't need to do the x.py build. Right? It's a question about what is the thing we're actually trying to resolve there. Because x.py build at this point might have done multiple stages of rebuilding.
We've also reorganized.
Exactly. Incremental compilation has gotten better since then. That's right.
I'm not sure that path even exists on main today. So
right. I see your points then. But still, it'd be a good thing to redo. And anyway, this issue, the other thing I pointed out at the time, or rather a year later or so, half a year later, was that we should figure out if this is actually inherent to Rust build or if it's something that is a broader issue with incremental compilation.
You know what? You touched on an important point. He's building stage 2.
Right.
Or he would have been building stage 2 at that point.
That's right.
That
we don't have a way of knowing the compiler itself, right? Because we don't have a way of saying, oh, well, the compiler itself didn't change. So you don't need to rebuild all this stuff. Yeah.
Yeah. Because unless we got a bit for bit identical Rust C out of stage 1, there's definitely no way.
Even if we did, are we smart enough to know that it's? Because we look at the timestamps, right? Do we actually look at the?
Yeah, I guess I assume we look at timestamps because I don't think we have bit for bit identical.
We don't have the deterministic. We've been working towards it, but I don't think we have it yet.
Or at least maybe we do, but it requires like relay control situations or something. So I guess I'm almost inclined to close this, given how old it is, and I pretty much only use -I incremental when building Rust C nowadays anyway, and I wouldn't describe it like this, but I also don't build stage 2, and I don't think anything has really changed there.
Wait, so when you say I only use -I incremental, do you mean the sense that like you don't change the incremental, you don't use incremental equals true in the TOML, and that's significantly, those two paths are significantly different?
Oh, no, that's just, I started using that before that was the default, so I just type it out every time. But
right, but I'm still trying to understand.
I'm saying I never use non-incremental.
But they don't either. I mean, they started with incremental in this example, and they're not saying switching on incremental is slow. There's okay.
I'm just saying incremental seems to be working for me.
Okay. Your point is that since in your experience, this kind of thing runs fast now.
It sounds to me like the complaint here is really just that stage 2 and the incremental flag don't play together, and I'm not sure that. I mean, maybe it's worth leaving this issue open, but I think that's really the core issue here, is that stage 2 and the incremental flag don't really do what you'd expect. They build a stage 1 compiler in incremental mode, and that's probably really fast, but then stage 2 just builds another compiler again.
Right.
Probably what the bulk of the 15 minutes is doing. So I'm not sure that's even something in our
wheelhouse.
Yeah.
If anything, it would be a Rust build, like, we try to, make us smarter about when to rebuild stage 2. And in reality,
given all the x.pi changes lately, I'm not sure that this is even worth tackling anymore, since people should generally not be doing stage 2 builds. So
yeah. Okay. I'm going to make a comment that, this issue is described. We believe it was going all the way to stage 2, which imposes work that is very hard, that is hard to avoid.
Something that make worth trying is just the same example, but it's just stage 1. Like,
I
don't know. Yeah, we have been doing that all the time. Meanwhile, we write code in the compiler, but I don't know, just with that file, just in case.
Yeah, it would probably be a good idea to double check that, like, touching the equivalent of this file when building a stage 1 is indeed fast, right? So I think, so we have two options. I'm going to finish writing my comment first of all, which is just to summarize the sort of hypothesis we put forward, which is that we think that the issue that was described here is probably an artifact of building a stage 2. The question is, so do we close this issue outright, or do we, still want to actually do the experiment of just double checking that this thing is fast when you do this? I don't care. I'm
not really touching the file and trying this out.
You're gonna just try it yourself?
I have a fresh compiled version of the compiler, so I can just.
I'm gonna just go ahead and closing as presumed fixed, because I don't want to forget to do it later. And we can reopen it if it turns out there's something about that file that means it really is an issue. Okay. Next up, unexpected panic whilst using base 64 macro Oh, sorry, this is 54960 is the issue that I just opened up. And it is unexpected panic whilst using base 64 macro from binary macros crate. And oh, I'm sorry, I just realized that the way I've been linking this for some reason, it's been doing it in like, what do you call it, like code mode in the markdown. Anyway, sorry. So
can you repeat the number? Sorry.
Yeah, the number is 54960. Linked from the agenda hack MD. Someone reported okay. So this was opened again like 2 years ago, but in April of this year, it apparently doesn't ice anymore. Okay. Closing as not as fixed, right? I mean,
is there an easy? Can we just add a test for this, or do we actually have to set up an incremental session?
Well, we don't know why it happened.
I guess we'll have a backtrace. Oh wait, we do.
We have a backtrace, but it's a typical, like, index out of bound, len is 10,
yeah,
index is 10. I don't think we're going to be able to replicate this readily.
And I mean, even if we did, minor changes in the rest of the incremental system could just completely void the test, and we'd never know. So
yeah,
I'll just close it.
Okay. So what's the best way to phrase this? Unfortunately, we don't like. This bug is old enough, and that we don't and doesn't have enough. I hate to act like it's the fault of the bug reporter, but like the reality is that
I think we could just say closing since this doesn't ICE anymore, and feel free to comment or reopen or whatever if you see this again. But.
Yeah. If you encounter again, please reopen. Hopefully with info about the pre and post states of your code base, so that okay. Yeah. Yeah, I really would love to maybe try to figure out some way to, we've talked about this before, try to get better bug reporting mechanisms in place in terms of having the pre and post states for the source code more readily available. Okay, where are we? Time check. We've got 7 minutes left. Is this, I want to double check with everyone else. Like, I actually think this is useful to get through these, but I also don't want to, if people feel like, oh, this is not a good use of synchronous meeting time, then we can, just end the meeting. I don't want to force everyone to sit here while we're doing triage necessarily. But if nothing else, I like closing bugs. All right, we'll keep going, I guess.
I think this has been useful, and it sounds like there's maybe some new project ideas that have come out of the bugs.
Yeah. All right, so let's keep going then with more of these. So we got the next one I see is 53929. Incremental compilation fails when a generic function uses a private symbol. So what is this? So this is again an old bug, 2 years old, like others. I'd have to read it more carefully to understand what kind of situation it's talking about, but there's some static symbol that's being used that's, well, let's see. Something about using LV, using config, using attributes to cause the symbol to be, wow, this is really in-depth stuff. It's like changing the exported name of various symbols and the incremental compilation is for some reason then failing to compile. Michael said, yes, we don't handle this kind of thing very well. And that's basically it. Like something like Michael did experiment with ways to try to resolve this by basically not splitting the generic and non-generic code into two different CGUs, and it didn't. The form set was too big. So there are a couple of questions here that I can immediately ask. One is, should we consider, like, how big a problem is this in terms of, I imagine that, for people, there may not be a large group of people that are using this, but for the ones that are using this kind of feature, it sounds like this could just readily like cause them to say, I just cannot use incremental compilation at all, which is a bummer, right? And it's in fact the default when you just do cargo build, so that's even more of a bummer, right? To have this kind of thing that's like they have to explicitly disable it, and I'm betting that the error they get doesn't tell them that, right? So this actually sounds like a potentially serious issue. Right?
Yes, it's probably uncommon, but
it's probably very uncommon.
Your analysis is totally correct.
Says these private symbols are useful for low-level FFI work, e.g. the linker on Mac OS, iOS will deduplicate selector names only if they have a private symbol name.
I feel like this is sort of the gray area of like between Rust the language and then Rust as it actually runs on the metal, and especially on specific platforms. Like it sounds like a lot of this is platform specific linker behavior, which is something that I don't think we really
could we do something
that.
if we do some, yeah, sure, if we try to like get into the details of platform specific linker behavior, we're in trouble. But I'm imagining like a stupider solution of just saying like if something's tagged with export name that we disable, like we can do a simple static analysis ahead of time and be like, if it has this attribute, don't use incremental compilation, right? And if someone and if it was the default, and maybe issue a warning or some sort of like diagnostics, just info thing, being like, hey, you may think you're getting incremental compilation, but you can't because we don't support this thing yet. It depends on how, the diagnostic question is separate, right? But the first thing I would wonder is, should we consider that kind of thing here, just in terms of addressing this use case, or potentially issuing the diagnostic, or don't disable incremental compilation, but at least issue a diagnostic saying you've turned on incremental compilation and you have an export flag. You should be aware that there are problems with certain kinds of export flags. So if you see a linkage issue, try disabling incremental compilation, right? That would be a way to actually give people direction towards how to resolve this problem. If they hit it, without actually hitting anybody, that the only hit would be the people that are using export name, and it works with incremental compilation, and they get this diagnostic that's in fact not useful to them. And we could, have ways to disable the lint for the cases where they could say explicitly, with a lint thing saying, I know about this case works, it's fine, don't issue the diagnostic here, right?
Yeah.
Like, I think that's a pretty simple, the question is, one, we could try to make it actually, found some way to make incremental compilation work with these cases, but I'd be more interested in just producing something to tell somebody about the problem up front as a short-term thing here.
I'm not sure why is this an incremental compilation issue and not just a how we do partitioning, based on my reading of the issue. It seems like
that's a good question.
It has private linkage, then it gets put in the static gets put in the same cogen unit as non-generic stuff. And so when the generic cogen unit references it, it gets confused. I don't know what that has to do with incremental compilation. Unless I'm missing something.
Well, do we do that same partitioning of generic versus non-generic for when we do cogen units, for example, for parallel?
think so.
Yeah, there's only one, as far as I know, there's only one. Well, there's two paths through the partitioning code. There's, did you turn on the only one CGU flag, in which case we like just kind of fail fast to the put everything in one CGU and then continue. And then there's the other case that has the more complex logic for generic and non-generic and merging and all that stuff. So even if you're not using incremental compilation, unless you're using cogen units equals 1, this still comes into play.
Interesting. Okay, so but is cogen units equals n the default?
Yeah, I think the default's like 16 or 64, or maybe much larger than that, actually.
On release too, or just on debug?
I think even on release, because I've definitely seen blog posts about, so you want to minimize your Rust binary size, set cogen units equal 1, or get the most performance, set cogen units equal 1.
Yeah, okay then. So it sounds like this is a broader question. I mean, there's no team that's just about partitioning issues, right? I mean, I think we are the group that would be the one that would still be addressing this in that case. But it's a good point that it may be a broader problem.
If there was a component to it that only triggered when it was incremental, when it's the second compilation. But my reading of this says that's just the first compilation.
Yeah, okay, that's a really good point. I think the answer here is there's some further investigation warranted to find out how broad a problem this is. If indeed it's your hypothesis right, that this is just about partitioning in general, and that therefore people should be hitting it whenever they use private symbols.
It fails with an LVM error in the first one, but the second compilation will still work. Seems to be what the issue is, based rereading the initial one. Like you can see the first cargo build the guy runs says LVM error, the second one works.
No, the second one had release mode.
Oh, is that the difference?
Yeah, and that's why they thought it was incremental, which is a sign that something's up, right? In terms of like, I don't know if back in 2018 we had release mode use multiple compilation units by default.
We did change that at some point, but I don't remember the timetable on that.
I think the basic, okay, so our hour is up. I think the right thing here is we should do nothing right now, right? I think the further investigation is warranted before we do anything. And then the first thing I would look into is what's the current behavior for private symbols in general? Like this is a very specific test case they gave, but I could imagine other ways to write it that's just not this, this detail. Like in terms of, you don't have to have architecture specific stuff. I don't think you can just make private symbols, period, and then see what happens. And so find out what happens to private symbols, find out whether there's anything that's connected to just incremental compilation or if it's something general against partitioning, and then consider like, the solution space then. But given that we haven't seen anybody complaining about this, so my hypothesis based on what David said is that, maybe this isn't affects every kind of partitioning, which means since we haven't seen other complaints, I guess maybe everyone using private symbols also then knows, oh, well, then I have to turn off, I have to do CGU equals 1, right? And they know enough about the low level details plus the way the Rust compiler works that they don't report it as a bug, they just fix it. Don't know. Anyway, that's my attitude right now, is to say don't do anything yet, but I suspect that we still might want to do something here because the user experience sounds very bad. For when someone tries to do this and hits this problem and says, why the heck am I having this problem? It would be something where I'd be pretty annoyed as a user about this personally. Okay, our hour's up. Thank you all for attending. This was really great. I'm really pleased with what we got through today. And I'm hoping to be more effective in the future as a personal member of this group. Yeah, okay. Do you all think that the biweekly cadence is good? I know that Wesley and I had discussed privately, like, should we do weekly or biweekly? Given how little I've been doing, I'm happy with biweekly cadence, but I'm curious whether you all think there'd be more utility in trying to meet more frequently. I suspect right now not, but any thoughts there?
For me, it's fine. I don't know.
Yeah, fine so.
Let's stick with biweekly then, I think. That's great. And this time slot is good for everybody still?
Yes.
Yeah.
Great. Okay. Thanks, everyone. Bye.
Thanks. Bye-bye.
Bye.